x divided by x square minus 9. So how we can write? Uh, if we have domain, so domain is okay. How to find range? Can we write like this one? Y is equal to x divided by x square minus 9, or if we replace x and y, interchange the value of xy, x is equal to y divided by y square minus 9 multiply with x, we have x multiply with y square minus 9 equal to what? Equal to y. So if you divide both side by x and y, this side by x and y, x cancel with x, this side y cancel with y. We have on right side y square minus 9 divided by y equal to 1 over x. Okay, this y is for y square and also for 9. Y square divided by y minus 9 divided by y. You can cancel these. We have y minus 9 over y equal to 1 over x. Okay, try if you can separate y and y minus y. If you cannot separate, so this domain is not possible. Then you can find, but we use another theorem, the theorem of we have yes, yes, uh, wait, induction theorem, but full name is not induction. Yes, mathematical induction. So with the help of mathematical induction, we can find only one y, but it's not your level, so we cannot here solve this one. Y square minus 9 divided by y. So after this, we cannot solve. We cannot separate y because we need only one y. So if not possible, only one y, so then we use mathematical induction, but we cannot find this one without mathematical induction. And then how we can find the range? We can find with the help of graph. So with the help of graph calculator, if you draw the graph, then you can find the inverse function. Yes, inverse, no, range of the function. Clear? And we discussed this issue in previous classes that if you cannot separate, so then range is not possible. Okay. What about third one? So third one same. If you can simplify, so simplify. If not, so then with the help of graph you can find. But third one is easy. You can x plus 3. No, you cannot. X square plus 9. Try this one, but this will give you cubic equation, not square equation. So again, you cannot find domain for this one. Okay, only domain is possible, but range cannot possible. Then you need to find with the help of the graph calculator or using mathematical induction, but we are not going to solve with the help of mathematical induction. No. Okay, we were discussing this one, the asymptotes. That what are asymptotes? So we have 1 over x equation, 1 over x giving values 1, 2, 3, 4, 5, 6, and 7. And you can see here that as we are giving values 1, 2, 3, 4, the value of y is decreasing. 1, 0 0.5, 0 0.33, 0 0.25, 0 0.2, 0 0.16, and 0 0.12. If we give 8, so there will be 0 0.7 something like this, 0 0.07, then 1 over 9, 0 point something, 1 over 10, 0 0.1. So as we are moving toward positive values like positive x-axis, the graph is moving toward the value of function is moving toward the 0, but it will never 0. Why? Only if we give 0 values, so then this will show infinity. So the point when a graph is moving toward but will never touch can never touch that point is called asymptote. And there are two type of asymptote. One is vertical, second one is horizontal. On right side, you can see the graph. You can see here, the graph is moving toward y-axis. As you are giving values, so y graph is moving toward y value, but it will never touch this y-axis. Same on x-axis, when you give values, so the value of function moving very close to the x-axis, but it will never touch this x-axis. So these 2 points, yeah, these two axes, y-axis and x-axis, are x is equal to 0 and y equal to 0. These values are not possible. When you give these values, so the function will be undefined. So undefined, it will never touch x value and y value. So therefore, if we have function, so how we can find the asymptotes? Two type of asymptote: vertical asymptote and horizontal asymptote. So vertical asymptote is actually the simplified form of rational function. When you solve a rational function and find the domain, so same the domain constraint and asymptote constraint, these are same. Like what? We have 2x square plus 10x plus 12 divided by x square minus 9. So first you need to simplify with factorization. Factorization of the numerator is x plus 3 and 2x plus 4. Divided by, we have x square minus 9. We can write x plus 3 and x minus 3. When plus cancel with plus, we have 2x plus 4 divided by x minus 3. This is simplified form. Now this denominator is important. X minus 3 not equal to 0, or x is equal to, yeah, x not equal to plus 3. This 3 point is called asymptote. It means that you can give any value to the function, but only 3 value is not possible. And the graph will never touch the vertical x-axis on 3. Like what? We have graph of this one. Yes, you can see here. Function graph is on both sides. You can see on right side and you can see on both. Can you see this graph? It will take time. It's uploading. Can you see now? Tell me. Okay. Okay. So x is equal to 3. Isn't to this one? X is equal to 3. This point. So graph will go closer to this one. Same this side, but it will never touch this. X is equal to 3. So is, if you remember from limit, that we use the concept limit x tends to a video. A means any video, like limit of x tends to 2 video, 3 video, or 4 video. Like in Dari we can say takarubba 2, takarubba 8. So the graph, actually this limit tends to what? This tends to 3, but it will never touch 3. X tends to, yeah, x takarubba 3, but actually x is equal to 3 is not possible. So that point, when graph can never touch that point, is called what? Asymptote. Or you can say that a point at which we cannot define a function, a function is not defined, is called asymptote of this point. So if we have previous function, this one, so if you give value x is equal to 3, so this function will become infinity. 2x plus 4 divided by uh, 3 minus 3. It means 2x plus 4 divided by 0 equal to infinity. Here in this asymptotes, we use symbols, like what? For example, if we have x is equal to, let's suppose, 4, we have graph on this side and we have graph on this side, like any video, like this one, but it will never touch this x is equal to 4. So then we can proceed toward 4 from right side, and we can reach 4 from left side. If we take this right side, this one is left side. So we can say that x tends to 4. If we write plus 4, this means that the graph is approaching from right side. Plus means from higher values, from 5, from 6, from 7. If we take x approach 4 but minus means that the graph is approaching toward 4 but from lower values, like from 3, from 2, or from 1. x तकरुब व मुस्बत 4 or x तकरुब व minus 4. Plus means that we are moving towards 4 from higher values, from 5, 6, or 7. X tends x going toward minus 4. So minus means that we are approaching 4 from lower values, from 3, from 2, or from 1. We Yes, this one. We use these symbols: x approaching plus a, x approaching minus a, x approaching infinity, plus x approaching minus infinity. So you can see here on this side, when you are giving values to x, like the value of 1 over x, 1 over 1, then 1 over 2, then 1 over 3, 1 over 4, the value of x is increasing, but the value of y is decreasing, like 1 over 1, 0.5, 1 over 2, sorry, 1 over 1 is 1, 1 over 2 is 0.5, 1 over 3 is 0.33, 1 over 4 is 0.25. X is increasing but y value is decreasing. So this graph is moving towards 0, but it will never equal to 0. So we use these symbols: x approaching from right side or x approaching from left side. This one, x infinity, so x tends to plus infinity. On this side, we can say x is approaching minus infinity, but it will never equal to 0. It will never touch the x axis or y axis. Now, in next example, this is last example, we have x minus 5 divided by x square minus x minus 6. How we can find the domain? So simply factorize or simplify. If not, then you can factorize. You can write with the help of quadratic formula. Let's suppose we factorize. We have x square minus x minus 6. Factorization: x plus 5 and x plus 2 and x minus 3. But we don't have common between numerator and denominator. So then we have x plus 2 and x minus 3. So you can put these: x plus 2 not equal to 0 and x minus 3 not equal to 0. Because if you put this one equal to 0, then this function is undefined. Or x is equal to, yeah, x not equal to minus 2. This one, x not equal to plus 3. So now in this case we have two asymptotes, two constraints for the domain. Domain minus 2 not possible, and domain plus 3 not possible. If you give minus 2, this total function is 0. If you give plus 3, this total function is 0. Same, we have two asymptotes. Graph will never touch these 2 points, minus 2 and plus 3. So how will be the graph of this function? Okay, we have this function, the graph. Can you see? Okay, okay, it will take to load, but wait for it. So you can see here, we have 2 points, x is equal to 3 and x is equal to minus 2. These are called vertical asymptotes. Graph moving toward these points, but it will never touch the point. We have 1 point, x is equal to 3 here, and second one is minus 2, you can see here. So graph moving toward very close toward this minus 2 and plus 3, but it will never, because at these 2 points the domain is undefined quantity. We don't know the yes, domain. You cannot give 3 and minus 2 because output will be undefined quantities if x is equal to 3 and x is equal to minus. These are for vertical asymptote. We have rule for horizontal asymptote, but we will discuss horizontal asymptote in next lecture. Clear?